it'll just go that way at that speed forever, right? But we're not in a vacuum, thank you. All right, so here we go. Some things to define. We've got V naught. It's actually not V sub 0. That's for sequences. When you say like sub 3, you know, A sub 2. This has actually got its own little name and is pronounced V naught. V naught. It means it's your initial velocity. And then my favorite one, the initial height, where we launch something. And we're really just going over projectile motion. That's going to be what we're really going to focus on most. We did horizontal and vertical, which were kind of weird, but we're really going to be living in projectile motion, just like you did in physics, right? And they don't call it kinematics in most places. They call it statics and dynamics. Things in stasis are static, things moving are dynamic. That's what they're usually called, not kinematics. Kinematics are just like the equations used to solve statics and dynamics, basically. And so my favorite one, this one's called, why not?
Why not?
Why not? Why not call it why not? Yeah, I like that too. I'm going to put one note up here also, and this is actually on the formula chart. It's in the back of your homework. And the one I printed for you is separate. I made a little bit of change to your horizontal and vertical motion. So the note comes from when we're doing circular motion. Circular. You've got these equations on your formula sheet. They're a little different. You're going to have to calculate your V naught. Like all the projectile motions, we just straight up tell you, we launch it at this speed, unless we drop it. What would it be if you dropped it? 0. That's the one you have to figure out. Everything else we're just straight going to tell. We launch it at 150 feet per second. Something like that. Circular motion is different, and elliptical motions also. V naught is equal to your radians per second times your time. You'll need this on worksheet 64A. There's a Ferris wheel problem. That's just circular motion. They give you however many revolutions per minute. You have to turn that into radians per second and then stick a T on the end of it, and that's V naught. That's the only difference. Then you use the equations. Okay? It's just a subtle tweak. We're going to be spending our focus on projectile motion because I think it's more important for us. I'm not going to worry about the other ones. If I was going to focus in one area, it's going to be making sure I can do projectile motion problems very accurately. Okay? Okay, I'm going to label a couple things on this graph. Every initial velocity, every V naught, has a horizontal component and a vertical component. But you're going to see in the formulas that we gave you, it's already horizontal and already vertical. So let's go down and let's look at this. Stuff we know. Easy trig. Trig is easy now. What's the cosine of theta on this graph?
Oh, Vy over V naught?
Close. Cosine.
Oh, cosine. Vx.
Vx over V naught. And when I solve for the x velocity, the velocity in the x direction, you're going to get the velocity in the x direction is V naught cosine theta. Does that look familiar from your formula? Oh. The formula already had horizontal and vertical in it. You didn't need to mess with it. And then similarly, sine theta, now we'd have Vy over V naught. So if we solve this equation for the y velocity, or the velocity in the y direction, you're going to get V naught sine of theta. Horizontal velocity component, vertical velocity component. Now, our equations are not velocity equations, they're position equations. The parametrics tells you the horizontal distance and the vertical distance at any point in time. It's hidden from the graph. So when I go down here and I want to write the distance equation, Distance is the rate, the velocity times your time. So all you do is take that and stick a t on the end. Your formula sheet has the t stuck between v naught and cosine. I hate that. I just like it. It's just rate times time. Initial velocity, or your horizontal velocity times time, and your vertical velocity times your time. I always have my time on the end of those little components. You will be not given these formulas on a quiz or test. But what's the one area I'm going to focus on? Well, besides that, if I'm doing a parametric specify. Yeah, if I'm in parametric applications, I'm really going to make sure I know projectile. Okay? And this is really the only example we're going over. Y'all are smart kids. So, another thing. We're not in a vacuum, are we?
No, sir.
We're on Earth. We have the effect of gravity. So if we were in outer space, those two equations would be everything. Off it went, and it would just keep going. But since we're on Earth, gravity is going to pull you downward. It's not going to affect the x, it's only going to affect the y. So your x of t equation is the same thing. V naught cosine theta times t. Make sure that t is not in the parentheses with theta. It's outside on the end. You can still put it before the cosine, and the reason they wrote that way is so you didn't make that mistake of putting a theta t or something. That's why they did v naught t cosine theta in the formula sheet. I like this way better, personally. Now, we're going to do all our problems in feet just to make it easy for you. So the effective gravity is we're going to subtract 1/2 gravity times time squared. Now, what's gravity in meters? But you convert 9.8 meters per second squared to feet per second, and you get 32. And what's 1/2 of 32?
16.
That minus 16t squared was the 9.8. It's the effective gravity. Okay, and we're also going to change the initial height. So we have y naught plus sine theta t minus 16t. There's your vertical position equation. These are the two you need to have down. Remember, x is cosine, y is sine. Don't mess that up. People will mess that up. Yep.
So when we're doing it like on the quiz, should we use capital T or lowercase t?
I use capital T, but I don't care if you use lowercase. I just think capital T's are easier to write, and they don't look like plus signs.
Oh, yeah.
So I would suggest capital T. So there's your two equations. Now I'll show you how to use them again. And I'm going to go through a couple methods that will be okay to use, and I'm going to try to convince you. I had some stubborn kids in first period. Does anyone have an Inspire calculator? TI Inspire? Inspire, no? Okay, good, because they're just holding on. Oh, we got an 83, great. Can you check yours for a second? Do you have a solver? Do you know if you have a solver? Hit math and push up. Here's, let me peek. Do you have a solver? You will not be allowed to use the solver feature. If you don't know how to use it, great, because they're illegal. That's why you can't bring these calculators into a college math class anyway. Because you can program all your notes in there. Because they have letters, you can't use it. Does anyone know how to use their solver?
No,
You do a little bit?
I have no homework tonight.
TI-84s are a little bit better than the 83s using the solver, so you can plug in things. When is it 0? Just plug in solve equation 1 for 0. It's not allowed. The Inspires are way easy to use. It's basically cheating. So that's why these calculators were never allowed in any of my college math classes, ever. Yeah.
So can you use it on SAT?
Solver, if you know how to use it. TI-84s are allowed. So if you can plug an equation in, Jack, and you can plug it in and you know how to use your solver, you can solve it for any value.
Oh my god.
Yeah. So you hit math push up for solver, but we can't use it. Okay? So anyway, let's go through this process, and now I think it'll make more sense today. You only have much to do tonight. We'll be able to finish yesterday's worksheet either a little bit today, a little bit tomorrow. Right? Tomorrow's what, Thursday? Mm-hmm. Yeah, we can get most of it done in class tomorrow, 64A and 64. All right? So don't feel like you have to do a lot of homework. You can even start 65 if you want, and we'll try to come up with something for Monday. So here we go. Cannonball, fire into the air from a height of 5 feet. That's why not. Y naught equals 5, initial height. Did you get it working? Hence those calculators being illegal in college, algebra, or pre-cal, or calculus. Hopefully, if they allow them, then you know you're going to have a bunk college. Theta is equal to 30 degrees. Is that on or off the unit circle?
On.
Oh, great. That's going to make things a lot easier. And your initial speed, V naught, would be 76. When you're given angle of elevation or inclination, however they describe it, is on the unit circle, it's going to make things a lot better because I'm not going to have to worry about taking and putting like cosine 30. I'm going to actually find out what that is and to reduce my equations. So I'm going to write my equations. So x would be V naught cosine 30 t. I put the t on the end. It makes everything a little bit easier. We should go coefficients, numbers, then variables anyway. So it doesn't really make sense to put cosine 30 is just a number. What is cosine of 30? Small, medium, or large? X at 30.
Oh, yeah.
Large, so it's root 3 over 2. So I'm going to reduce this to become 76 times root 3 over 2 times, which makes 38 root 3. If it's on the unit circle, I suggest emphatically that you reduce it by hand. It's going to make your equations a lot easier. It's going to make solving things a lot easier. Typing them in the calculator is easier. All that. All right, so y of t will be 5 plus 76 sine 30t. What's sine of 30?
1/2.
1/2. 5 plus 76 times 1/2. And that's going to reduce to 5 plus 38t. It's a lot nicer looking. If it's on the unit circle, try to reduce it by hand. Even if it's a root, it's either root 3 over 2 or root 2 over 2 or 1/2. That initial velocity will be divided by 2 and you stick the root on the end, basically, or you just divide it by 2 if it's a 30. All right. So from yesterday, once you wrote your equations, what should we do with them? Put in your calculator. So make sure you check your mode. Go ahead and make sure that you're putting it in degree mode. I know our equations don't have sine and cosine anymore, but the calculator will still need to be in degree mode anyway, because most of your other problems will. So go down to degree mode. And I'm going to go through why this is, I'm going to show you the horrible way to do this. Using your calculator. I'm going to warn you now, time is going to be an issue on quizzes and tests in this unit. There's a lot of stuff to keep track of and think about. The tests aren't really long in themselves, but they're not exactly easy, so you want to really make sure. Now, 38 root 3, make sure you push to the right before you hit t. You don't want that t underneath your radical. So you want to stop the radical. If you have an older calculator, it's easier to just use your parentheses, stick the t on the end. Okay? Now, 5 plus... When you hit x, the t comes out in parametric mode. Now, should I hit the graph button? Where do I need to go? Really important. Check your table of values to see how long the event took to happen anyway. And so I'm going to look at my height, and I'm going to look at the first negative. How many seconds was that?
3, wasn't it?
3, so I probably need like 0 to 5 for time, or 0 to 3. Look at your horizontal distance. Do you think 200 is big enough to see the whole thing? Yeah. So I'm going to go my window after I check this. So 0 to 5 is great. Make your t-step 0.1 every single time. X-min is 0. X-max 200 because we had a horizontal distance like 190 or something. So I went a little bit bigger so you can see it. And then my y, I went 0 to 50. Okay, now before we go, remember, go to the left of your x1 hit enter and make sure it's the line with the ball on the end. Because it's cool. Remember doing that?
Where is that?
Back into y equals, if you go left to the x1 and hit enter, you'll be able to change what is graphed. You can do thick lines, thin lines, dotted lines, ball, line with ball. We want line with ball. Now when you hit graph, let's see it go. Woo! Cannonball.
Oh, nasty.
We're shooting a cannonball, why not make it a ball? You know?
What's the X value?
That being said, we're rarely going to use this graph for anything. It's just like a cool thing. All right, to interpret the situation, get you an idea of what's happening. Now you can try to hit trace. Dave, you got a question?
It'll make it just
Okay.
look like.
Now, I'm going to tell you right now, you can hit trace and try to find values. Sometimes they come out, sometimes they don't. So we're not going to do the thing that works sometimes. Right. So after you have it, set window, you see your graph, we're going to use the equations to find times that we're looking for when things happen. Once you have a time, you're going to plug it into either the x to find an x answer or the y to find a y answer. Okay? And we're going to do this by hand, because watch this. When would it hit a ground? What am I trying to find here? What is that called in Algebra 2? Trees have them. They hit the ground. It's the roots. The zeros of the function. Okay? This one actually comes out works, but if you wanted to find the zero, remember you would go to second trace, zero function. Remember doing that last year? The parametric doesn't have it. It's got a bunch of calculus stuff. It does have a value, so if you knew a time we're looking for, you can plug in anything you want there and it'll tell you the horizontal and the verticals. It'll plug in at that time into both the x and the y equations. But we don't know the time it hit the ground, did it? This won't find it.
Wait, how did he get?
You can get an idea from the table. When about should it be? Between what two numbers? Between 2 and 3. We know our answer is between 2 and 3, but we don't know exactly when. This is what some of y'all were doing yesterday. Going back, putting it back into function, rectangular mode, going back to y equals 38 x minus 16. Oops. Did anyone do this yesterday?
No.
No? No one? I saw it in every class, I thought. Go back to y equals. And now, would you have to reset your window again? The x is now time when you're back here. So, you remember how to do your maximum and minimum? Your zero function? This is a pain. Because then you have to be switching your windows in and out. I'm not going to do it. Okay? So I'm going to go back to parametric mode, and let me show you how I'm going to do it, because this is the most efficient way. Whether y'all agree or not, this is the most efficient way. Trust me. Okay? Don't fight it.
Let's fight right now.
Well, students are like, I'm just not going to do it. I heard some. I'm like, go ahead, and you'll run out of time on the test. Just trying to help. Besides, a lot of these calculators aren't really allowed anyway in a lot of college classes in math. So this is what we're going to do. The two most importants about a parabola are the vertex and the zeros. You have two formulas for that.
Negative b over 2a.
Negative b over 2a is the axis of symmetry.
Yeah.
I'm going to use quadratic formula to find the roots. And this, instead of calling it x equals, here, I'm going to go ahead and move this up a little bit. Let me erase that. All right, here it goes. Quadratic formula. Which is basically the axis of symmetry, negative b over 2a. And you see the discriminant, the square root b squared minus 4ac? That's how far left and right from the axis of symmetry you go to find your roots. Now, I didn't teach y'all in Algebra 1, so I'm going to show you how the best way to do this formula. It's really, I don't actually even write this down. Y'all should know this by heart, so I'm going to go ahead and erase it. Mr. Grumbacher's 5-year-old knows it by heart. You can sing the whole song. Just sing it to Pop Goes the Weasel. Negative b plus or minus squared. All right? Y'all know this.
No.
This is the way I do it. 3 blanks. I've never in my life typed in everything into all of these blanks at once. The space shuttle, even though it's dangerous, right? We learned that. They don't just build all the pieces and just stick them all together. They build them like little components and they put systems together. So I just do this as 3 blanks, and underneath, I just do the hardest part, the discriminant. You know why it's called the discriminant? What word is it? Yeah, what does it sound like?
It discriminates.
It judges, it discriminates. Just by finding the value of this without putting it in the radical. I'll never do b squared minus 4ac and the radical at the same time. The reason you do this first is it tells you if you have any solutions at all anyway. If it comes out positive, you have 2 real solutions. If it comes out 0, there's 1 solution. If it comes out negative, there's no real solutions. That's why I always do this separate, all by itself. And here's your equation. T squared plus 38t. You don't have to put it in a standard form. Just remember the coefficient to your squared is your a, the coefficient to your linear is your b, and the constant is your c. A, B, C. You can just straight up label it right here. That would be C, B, and another technique. Use parentheses, so it's B, so it's 38, negative 16, and 5. Okay. So let me show you how I do this real quick and quickly and efficiently. I'm explaining so it seems like it's taking a long time. This is the fastest way. Now, put out of your screen. Don't do this separately. I see kids do 38 squared, then minus 4 times negative 16, then times 5. They do it separately, and it kills me inside. As long as you can fill in the blanks, you type it exactly what you have written. That's it. Type in exactly what you have written, and then hit enter. That's the hardest part to do in quadratic formula, folks. The hardest part is to realize you need to do it separately. Do the b squared minus 4ac discriminant without the square root all by itself. How many solutions are there if it comes out positive? 2. Now all you have to do is plug in your blanks. Negative b is the first blank. 2a is the denominator's blank. And it's always that way. So switch the B, first blank, double A, second bottom blank. Now, here's kind of a tip. You don't need the plus on this. What's on denominator, positive or negative? So we need a big negative. The biggest negative on top will give us the biggest answer. So I'm just really going to use the minus. So at this stage, I'm going to go ahead and type in negative 38 minus square root 1764, push to the right, hit enter, divide by negative 32. There it is. When you do this a couple times, it's so fast. Even if you have sines and cosines, could you put like 38 cosine theta in here? You sure could. You can put it in there too, and it's not going to be that bad. Just use your parentheses. Don't do it separately. Type it in once. It works just as easy. All right, so what should be the height? What don't you know? Yeah, so we need to plug in 2.5 into the horizontal. So it's going to be x of 2.5 equals 76 root 3 times 2 point. Now you can just type that in. We need to find the x equation at 2.5. So we're just going to type in 76.
38.
Oh, is that right? 76? Yeah, my bad. 38 root 3 times 2.5. Push to the right, times 2.5, 164. But anyway, once you knew the time, I will show you that the parametric graph is pretty cool for this. Check this out. If you go to calculate, it has all this calculus stuff, but the first one says value. If you just do the quadratic formula for the time you're looking for a root, 2.5, you hit value, the graph comes out, and it's going to say t equals blank, and you just type in 2.5. There it is. Okay? This works really, really well for a vertex. This works really well. Yeah, Drew.
How do you get the T?
Oh, so you go second trace for the calculate, and it's the only one for us is value. So you hit 1, and then it'll graph it and give you t equals. But in order to do this, you have to know what time you're looking for. And once you know the time, you hit enter, type in whatever you want, and it'll tell you the x and y at that time, the horizontal and vertical. Okay, how high does it go?
Negative B over
Very nice,
2A.
Brian. It's the vertex, so I'm always going to use negative b over 2a to find the time at the vertex. It's way easier. It's going to be a lot easier than going back to your calculator in the rectangle and trying to do max and min, left bound, right bound, enter. It's a horrible thing to try to do. So we're just going to do t equals negative b over 2a. And you can actually find the horizontal distance at the vertex, everything. So t equals negative b over 2a. What was the b here? So it's negative 38 over negative 32. That is not difficult. It's way easier than trying to do this max and min function. I don't know, I mean, it's great, it's cool to have technology, but all this stuff was done before the light bulb was even invented. And a lot of it's easier than with technology. So, you know, tomato, potato, whatever, I'm biased. 1.1875, I think is what you get. Now, Drew, we can go right back here. If you want to use technology, second trace, t equals 1.1875. Bam. But we want to show our work, so I'm going to do that. It's not hard to just use the function. You may forget what the solver thing is or the value thing is, and you're going to be, where is it? And I'm like, I don't know. I can't tell you. Do the best you can. So you plug it in, and your height is?
27.5.
Now, I went ahead and solved for the x also because we'll need it on our tabla or table. How many points is great for a quadratic?
5.
3. I'm just going to use the initial, the vertex, and the root. Even though this has more rows than we need. So at t equals 0, the x was 0, the y was 5. Here, let me scoot this up a little bit. Okay, that's as far as it'll go. And let me unplug this one. It's all about using your horizontal and vertical equations to find the time. And once you know the time, you use the time in the horizontal and vertical equations. All right, so t equals 0, the x was 0, the y was 5. Height and feet. When you're drawing a graph, you need to label what's on the axes, to be honest. Height, and then what are you measuring them by? And then this one will be horizontal distance. Now, I didn't, there is no special name for horizontal distance, like vertical distance is height. So, girth, maybe. Okay, so we have 0, 5. Now, we need to go all the way out to, what, 160 something? So let's see if 20, 40, 60, 80, 100, 120, 40, 60, yeah, that'll fit. 20, 40, 60, 80, Now, at 1.1875, we were at and 27.563. Right there. And at 2.5, we were at, what was it, 164.5? Getting your arrows of travel on those is a parametric. You always need that path of travel. So hopefully this made more sense today. Like, to kind of recap it, do the same things we did yesterday. But once you get it graphed, you're just going to kind of use that graph. Maybe once you find a time, then you can plug it into value. That's really it. You're not going to use this graphing calculator for very much. You're going to use just a normal calculator features. All right? But you do want to get it plugged into parametric so you can interpret what's going on. You can get a general idea by checking your table. How many seconds about did it hit the ground? We do that with between 2 and 3. You know, we're using it for that. But then you're going to use the quadratic formula for your roots. One that hits the ground, negative b over 2a for the vertex. It's the fastest, most efficient way to do these problems. Okay, and it works the same every time. So what I'm going to do now is pass out your tests. You can look at your tests. We can work on this 64a and finish it. You know, tomorrow we're going to have a lot of class time, so don't feel like you have to cram a bunch of homework in tonight or anything. All right? Got regionals Friday? Yeah? How do you think you're going to do?
I think I'm going to do alright. Usually there's not like...
You know who's in the region, right? Or do you not? Are y'all going against Houston or no?
Not a lot of... I think Mansfield is in Mansfield, so it's in Dallas.
So you might have some people from Dallas.
Yeah. For some reason, though, the Mansfield High School against us, and they're really good.
They are.
Yeah.
Because you know from the club. Yeah.